Hello my dear children of class 11 science. Today again we do continue with the unit, that is unit number 9, kinetic theory of gases. Okay. Now in today's class we again continue with the expression of ideal pressure that we already derived in the last class. Okay. Now pressure, that is the pressure of an ideal gas, can be written in terms of the kinetic energy, also called the translational kinetic energy of an ideal gas. Because you know that when we take the ideal gas, molecules of the ideal gas, these gases are always in a state of motion. That means the molecules are always in a state of motion. Okay. So due to this motion, the molecules collide with the wall of the container. Okay, wall of the what? Container. And they exert a force. Okay, due to that force, okay, on a given area, they exert the what? Pressure. That's why the pressure can be measured in terms of what? The kinetic energy of the gas. Now for that, let me just start with the relation that we have done already. Till last class, we derived the expression of pressure by the relation P equals to 1 by 3 Mn. Okay, let me write Mn by B into capital B into B mean B square velocity. This is called mean square velocity. So this sign is called bar, but we call as mean square velocity. That means the pressure of an ideal gas, that is P equals to 1 by 3 Mn by B with mean square velocity. Now out here in the expression, if you see M, as you know, where M is the what? Where M is the mass of each molecule of gas. This is the mass of what? Each molecule of a gas. Okay, every molecule of gas has a mass, that is small letter m, and there are certain number of molecules of the gas, and that is n. And n is the what? Total number of molecules. N is the total number of molecules. Total number of molecules of the gas. Molecules in the gas. Okay, let me write in the gas. And you can see the symbol B. Capital B is the volume of a gas. Capital B is the what? Capital B is the volume of a gas. So whatever number of molecules which are present, all the molecules occupy certain space, okay, and it has what? Certain volume, and the volume is capital B. And you can see the symbol mean square velocity. This is actually called mean square velocity of the molecules of the gas. So again I write down mean square velocity. How to read mean square velocity of the gas? This is the mean square velocity. Mean square velocity of the molecules of the gas. So these are the symbol that you can see in the expression of pressure. In the expression of what? Pressure. But as I said, each molecule has mass m, but there are total n number of molecules of the gas. Then if I take all the molecules whose mass to be considered, that is given by m into n. So mn is the mass of whole gas. That's why I write down, I can write here that mn, small m and small n is actually the what? Is the mass of the whole gas. Okay, this is the mass of what? Whole gas. The total amount of gas which are present in that container or vessel has a mass, that is Mn. So from here I can say that Mn, the mass by volume, is expressed by density, as we have done in the previous video also. But let me just continue this. This is the mass divided by the volume, and you know mass by volume of a gas is the density of the gas. And this rho is the symbol. This is the symbol called rho, and this rho is the density of the gas. Density of the gas, which means the same pressure now we can even write in terms of density, but more important, we are trying to write the same expression of pressure in terms of energy. Okay, so I write on P equals to 1/3 of, yes, I replace this quantity Mn by B as rho and mean square velocity. Okay, mean square what? Velocity. But to write the same expression now in terms of what? Energy. Okay, energy. Okay, so let me just write it this way. 1 by 3. Okay, but to write this expression of pressure in terms of energy, what I do? I multiply by 2 in the denominator numerator and divide by 2 in the denominator. So 2 I multiply in the numerator, but I am dividing by 2 in the denominator, so that this can be written again in this way. So this 2 has been added extra. Now the reason I am writing this way is just to write the same pressure in terms of what energy? Kinetic energy. Now children, you have learned one of the chapter called fluid mechanics, okay, flow of fluids. At that time you learn about the Bernoulli's theorem. Okay, so in that case, if the liquid acquire number of energy acquired by the liquid is different, then the gas, the fluid means the liquid and gas, can also acquire the different pressure, like it acquire pressure energy, it acquire kinetic energy, it acquire what gravitational potential energy and all. Okay, now this particular expression, if you can see out here, that is 1 by 2 rho b mean b square velocity, is actually the kinetic energy per unit volume of the gas, per unit volume of the what? Gas. But we call this kinetic energy as translational kinetic energy, because in case of ideal gas, whenever the ideal gas under motion, they acquire random straight motion in all directions. Means every gas move randomly, okay, in a straight line in all the directions. Okay, that's why when the straight line motion or random motion of a body is concerned, or gas is concerned, we use the energy called kinetic energy, but that kinetic energy is called translational kinetic energy. Okay, as the other form of kinetic energy like rotational kinetic energy, vibration energy are also considerable, but that is almost negligible in case of the ideal gas. Okay, but depend upon the gases that we consider. But the more prominent energy which comes into play is called translational kinetic energy, and this is represented by E. So I replace this by letter E, and E is actually nothing but the what energy? Translational. Okay, let me use the word translational. Okay, translational kinetic energy. Kinetic energy per unit volume. This is important. Per unit volume of the gas. Per unit volume of a gas. Per unit volume of a gas. So E is nothing but 1 by 2 what? Rho b bar dash square. So that means energy, the translational kinetic energy of the gas can be written as 1 by 2 rho, the density of gas, and the velocity which we measure under this gas, okay, is called mean square velocity. What velocity? Mean square velocity. Okay, so E equals to 1 by 2 rho mean square velocity. Now let me replace now in the expression. So P equals to, now 1 by 3 into 2 means 1 into 2 means 2, so it is 2 by 3 into, now this whole quantity and I replace by what? E. Okay, so finally the expression you can see is P equals to 2 by 3 into E. So P equals to 2 by 3 into what? E. Now that means the pressure of an ideal gas is 2/3. This means 2/3 of its translational kinetic energy. This is translational kinetic energy per unit volume of the gas. So children, in the examination, if it asks to write a relation between pressure and translational kinetic energy, we can write this relation. Okay, but this relation is also equally important for solving numericals also. Okay, so the relation is pressure of a gas is equals to 2/3. This is 2/3 of the translational kinetic energy per unit volume of the what? Gas. So this is the relation between pressure and the energy. Okay, now the next term that we define as per the ideal gas motion is concerned, molecules of ideal gas is concerned, is called root mean square velocity or speed of the gas, and that you learn in the next YouTube video.